Hello Rakshit, how are you?
I'm fine.
Okay. Hello guys, I am Akshay Bhattan and he is Rakshit. He has cleared his Anglo-Eastern returns and on 20th of December, he is having his interview of Anglo-Eastern. Today I am going to take his mock interview. So let's see how it goes. Okay. Rakshit, are you ready?
Yes, I'm ready.
Yeah. Rakshit, introduce me yourself.
First of all, my name is RAKSHITH K. I come from Kasaragod, Kerala. I'm currently doing my BE in Mechanical Engineering fourth year. I'll pass out in 2024, and I have a CGPA of 8.3 in my Mechanical Engineering till the seventh semester. And I did my PUC in Canara PU College, Mangalore, and I have a percentage of 80. And I did my 10th in Kendriya Vidyalaya number 2 Kasaragod, and I have a percentage of 80. So that's about myself. And coming to my strengths and goals, what I want to achieve is that my strength first is my self confidence. I'm very confident in myself. I can convey my thoughts very nicely. My communication skills, I'm very much confident in that. And my strength, I'm really good in my leadership qualities. I have often taken many leadership roles in many projects that I have worked across in my mechanical engineering. And even in my school days, I have participated in many events and coordinated many events and extracurricular activities. That's about myself.
Okay. So in what extracurricular activities have you participated in your school?
Sir, I was really part of many skits, which went it through, like I reached state level for it, and even sat in a parliament for it, which is like a debate competition. And extracurricular activities coming for like I organized all the assemblies. I made sure all the mics were set up. Like it's little responsibilities, but I did that.
Okay. So, Rakshit, can you name the Chief Minister of Kerala?
Pinarayi Vijayan,
Okay. So, from which party he is?
Communist Party.
Okay. So, it's short form is CPIM, right?
Yeah, CPI.
Okay. Uh, so, you are from Kasargod, right?
Yes, I'm from Kasur.
Yeah. So, you happen to be sharing border with Karnataka, right?
Yes, we are sharing with Karnataka.
Yeah. Which Karnataka city is bordered with you?
Mangalore.
Yeah. Okay, Mangalore. Okay. So, can you tell me the atmospheric pressure of Kasargod?
It's one bar.
Okay. That's one bar. So, Kasargod is near sea level, right?
Yes, near sea level.
Yeah. Okay. So, Rakshit, can you name some ports in Kerala?
Cochin, the one that I am aware of is the Cochin port, which is the major port that is like widely known. But other than that, I'm not really aware of most of the ports.
Okay.
And in Mangalore also we have a port, Mangalore port.
Yeah. Okay. So I also happen to be from Karnataka and I have visited Kasargod and Bangalore both as well. So I'm asking you some questions related to that only. Okay. So this is a part of non-technical. Okay.
Okay.
Yeah. So what is so famous in Cochin other than ports?
Uh, I mean, I think they are famous. Like from a Malayali, I'm a Malayali, so I'm telling I love their accent. And
Okay.
Cochin biryanis are really good.
Okay.
And I mean, it's the way they talk. They're very really energetic towards each other. And whenever I'm like within a person with Cochin, I really enjoy spending time with them.
Okay. What I have asked is that why Cochin is so famous in India? What it is known for?
Uh, like from what I know, the metro is really famous. Cochin Metro.
Okay. Yeah. So as far as I know, there is an Indian naval base in Cochin, right?
Ah, yeah, Indian Naval Base. There is,
Yeah.
yeah,
As well
it
as
is.
Indian Naval Academy is also there for officers training,
Yeah.
right? Yeah. So if you mention this, it would be better. Okay.
Okay. Okay. So in non-technical, I'm supposed to know all the GK related to my area.
Yeah, it might be GK or some like science related questions, just some general knowledge, which you know, because you happen to
Okay.
be from Kerala, right? It's all about
Yes.
your locality. So you
Okay.
should highlight something which is very famous throughout the nation. So
Okay.
as Cochin, I said there is an Indian naval base in Cochin. So when you say there is an Indian naval base in Cochin, so it's known by everyone,
Okay.
right? So if you say Cochin Metro is famous, I am from Bangalore. I say Bangalore Metro is famous than Cochin. So it might create some kind of controversial. So that's why go for like big terms, like there is a Indian
Okay.
Naval
Okay.
Base and there is a Indian Naval Academy training center and all. Okay, so mention these points.
Okay.
So Rakshit, what are your hobbies?
Like my main hobby if I'm at home is I usually do DIY, do it yourself projects. Uh, Mostly involving repairing things, redecorating things, fixing anything that are broken. For example, if any fan's condenser is not working, regulator is not working, if anything needs fixing, like that's my usual job. My dad taught all of that.
Yeah, okay. So you said that you repair fans as well, right?
Yes, yes.
Can you tell me how fan rotates?
Electromagnetism. So what
Like,
happens is uh, electricity comes. So there is a motor in it. So this there is a rotor and there is a stator. So the electricity is supplied to this stator, and it is magnetically induced. And this rotor also gets magnetically induced, but in the opposite direction. So
yeah,
because of that, it starts rotating.
yeah, it generates EMF, right?
Yes, it generates an EMF, and because of
Yeah,
that, magnetic field, like it cuts the magnetic field of the rotor,
yes,
and because of that, it turns.
yeah, okay. So shall we switch to the technical part, Rakshit?
Yes, sir. Yes.
Can you tell me different types of pumps or classification of pumps?
So first of all is non-positive displacement pumps, which is rotordynamic pumps, and then there is positive displacement pumps. So in rotordynamic pumps, there is centrifugal pump, and there is axial flow pump or radial flow pump, which comes like anything can be happening. Now in positive displacement pump, there is rotary and reciprocating. In rotary, you'll get like screw pump, gear pump. Then it is reciprocating in which piston pumps will come and diaphragm pumps will come.
Okay. So, Rakshit, can you tell me how the suction pressure is created in the centrifugal pump?
So first the impeller starts turning, so it displaces a little bit of water, which creates a negative pressure in that area, like the eye of the impeller. So there is a little bit negative pressure in that area, and from the sump, the water at sump is at atmospheric pressure. So this negative pressure is lesser than that atmospheric pressure. Because of that, water gets sucked into the eye of the impeller. So that's how suction is created in centrifugal pump.
Okay. So the answer is not 100% clear because you said that it creates a negative pressure at the eye of the impeller. But I am asking, how does it create the negative pressure at the eye of the impeller?
A
When
vacuum is created.
the blades rotate, right? So it imparts this centrifugal force, and as this
Yeah.
centrifugal force is imparted, there is a kinetic energy imparted on the water molecules.
Yes.
Okay,
Yes.
so now this there is a reduction of space at the eye of the impeller, which
Yeah.
creates the negative pressure.
Okay.
So the pressure, negative pressure is the pressure which is lesser than the atmospheric pressure or surrounding pressure. Okay. Due to the drop of pressure, the suction effect is created. Right. So
Yes.
you need to explain in this way. Okay.
Okay.
Yeah. So can you tell me the difference between four stroke and two stroke?
Okay. In a four-stroke cycle, the cycle contains four strokes. In two-stroke cycle. Uh, Next is in two-stroke. For every two-stroke, there is a power cycle. In four-stroke, for every four-stroke, there is a power cycle. Um, in two-stroke, the power generated is generally high rather than four-stroke engines. Power to weight ratio in two stroke is much higher than four stroke. Um, Higher temperature and pressure are induced in two stroke rather than four stroke. Mm, Stroke length is much higher in two stroke than four stroke engines. Um Two stroke engine generally has ports and four stroke engines has valves. Two stroke engine mostly uses scavenging. Four stroke engine doesn't use scavenging. Mm, so that's all.
Okay. Can you tell me the difference between camshaft and crankshaft?
So, so the connecting rod from the piston is connected to the crankshaft. So crankshaft is the thing that takes the power, that rotary power, it takes and shifts it to the propeller or anything that we want to use. So what camshaft does is it controls the inlet wall, the exhaust wall through tappet and uh, through tappet. So it can controls the opening and closing of the valve. So crankshaft and camshaft are actually connected because it is usually connected either through gears or timing gears, timing chain,
Timing chains.
timing chains. So these are the main uses of crankshaft and camshaft and how they are different from each other.
Okay. So can you explain about turbocharger?
Turbocharger. So turbocharger is a very good method because we are using the wasteful exhaust gas and the kinetic energy from it and we are converting it useful for us. So what happens is this exhaust gas, it is connected to a blower arrangement. So what happens is this blower, uh, it's like two-sided. One side is blower, another side has an impeller. This exhaust gas hits the impeller and starts rotating this blower. So whatever is there in that engine room, that air gets sucked in by the blower and it's taken inside. But what happens is because of increasing pressure, the temperature of air is much higher. So we need to cool this so that there is a higher density of the air for the engine. So this air from here goes back to the engine. This high density air goes back to the engine. So the very good speciality is there is very high volumetric efficiency and we are actually using what is not useful to us. I mean, making it more efficient, the engine more efficient.
Okay. So using turbocharger, can we reduce the consumption of fuel or does it increase the consumption of fuel?
Uh, I think like because we are giving it more air, more fuel has to be used to burn it. So I think the efficiency is improved, but nothing related to burning the fuel. Turbocharger has nothing related to burning of fuel. It is more related to efficiency, increasing the efficiency of the engine. Correct me if I'm wrong. I'm kind of
Yeah,
up to
okay. So what do you mean by efficiency then?
efficiency is how much output we can provide by the input that we are supplying. The input we are supplying is air and the fuel. The output we are getting is how much power is going out of the crankshaft. That is the output.
Okay. So if efficiency is increasing, then the fuel consumption decreases or does it increases?
Like what I am telling is how much ever fuel we are supplying, that much proportional amount of work also we are getting because of turbocharger. So it doesn't,
Yeah,
yeah. So
that's what I
efficiency
understand.
has been increased.
Okay. So basically, it's like why we use turbocharger is to increase the efficiency, obviously. So as the efficiency increases, the fuel consumption also decreases. We can decrease the fuel consumption. Okay. So that's why the turbocharger is used. Right.
Okay.
Hope you're clear about it. Okay. Uh, Rakshit, can you explain VCRS cycle?
Okay. So I'll first of all tell all the main parts. First is evaporator, compressor, condenser, throttle expansion valve. So this evaporator is mainly connected to the system which we want to cool, and condenser is connected where we have to reject the heat. So first from the in the evaporator, from the system, the heat is absorbed by the evaporator. So we have a refrigerant. So this refrigerant absorbs the heat and turns into vapor state. So this low pressure, high temperature vapor goes through the sensing. There is a thing called sensing bulb, which senses how much degree of superheat or how much heat this thing has. So from the sensing bulb, it goes to the compressor. So this compressor compresses the refrigerant and converts into high pressure, high temperature, saturated vapor. So this high temperature, high pressure saturated vapor goes to the condenser. From the condenser, it rejects water either through seawater. It can reject heat, a little amount of heat it can reject, and some amount it might condense. So after that, it goes to the throttle expansion valve. So the main use of throttle expansion valve is it decreases the pressure and the temperature. As we know, pressure and temperature are related. If you increase the pressure, temperature increases. So a quick way to decrease the temperature is passing it through the thermal expansion wall. When it passes through that, the pressure also decreases, temperature also decreases. Like some amount of the refrigerant gets condensed, but some amount stays as a vapor also. It depends on the degree of superheat also. Like there is a sensing bulb, and the throttle expansion valves are connected through a capillary tube. So if the degree of superheat is very high, then throttle expansion opens more, so that more liquid gets more refrigerants get condensed. So that's the main working of VCRS cycle.
Okay, so actually, I'm not fully satisfied on your answer on VCRS, Rakshit, because when you are explaining something about cycle, no, you should start from beginning, and then by maintaining the chronology, you should come at the end. Okay, so first you mentioned about the evaporator. Okay,
Evaporator.
yeah, so that's the wrong thing. First mention about the compressor,
Okay.
condenser, thermostatic expansion valve, and then evaporator. Because evaporator is the device where the actual refrigeration is taking place,
Yes.
right? You are telling the refrigeration is taking place in the evaporator, and then you are explaining the cycle. So
Okay.
this is what gives a bad impression about the VCRS
Okay.
cycle. Okay. So whenever you are mentioning, please mention in the chronological order. Okay.
Okay.
Yeah. And go in depth. And you said that uh, the refrigerant, whenever it is entering into the compressor from evaporator, you said that it is a low pressure and high temperature. Okay.
Yes.
No, it is a low pressure and low temperature refrigerant. Okay. It is a superheated vapor at the
Yeah.
distal side of the evaporator. We agree that. But whenever it is compressed, it again becomes higher temperature
Yeah.
as that when it is at the distal side of the evaporator, right? So that's why the low pressure, low temperature evaporator from low pressure, low temperature refrigerant from the evaporator enters into the compressor. There, the isenthalpic compression is taking place.
Yes.
Okay. After compression, the high pressure, high temperature saturated refrigerant enters into the condenser, where, as you said, their heat rejection takes place at the seawater or something. There is a slightly drop in the temperature, and the pressure remains constant. After that, it goes to the dryer. In dryer, it removes the moist. Okay,
Yeah.
and after
Moisture.
that, it goes to the thermostatic expansion valve, where thermostatic expansion valve acts as an orifice, where there is
Okay.
a, sudden increase in area. That's why there is a sudden drop in temperature and pressure. Okay, so now this low temperature, low pressure liquid refrigerant or mixed refrigerant moves to the evaporator. Okay, so you need to explain this. Okay,
Okay.
and in evaporator absorbs the heat from the surrounding. So which ultimately results in the increase of temperature of the refrigerant. So now this liquid refrigerant is getting converted into vapor because evaporant is absorbing the heat from the atmosphere. So this heat is absorbed by the refrigerant. Okay,
Yes.
and the cooling effect is given to the refrigerants, right? That's where the cooling effect takes place, right?
Yes.
Yeah. So please maintain the chronology and explain this way, okay?
Okay, so start from the compressor.
Yeah, start from the compressor and end at the evaporator, okay? Yeah. So can you explain me the safeties of VCRS cycle?
uh, we have the LP cutout, like which is like if the suction pressure is not enough, if it's not mandatory, then it will automatically cut off the compressor. Then we have high pressure cutoff, which is when the discharge side pressure is very high, it automatically cuts off the compressor. Then is the lube oil for the compressor, and water shock, like if any water or incompressible fluid reaches the compressor, and if it can't compress it, then it will automatically cut off. um, yeah, that is some safety features for VCRs.
Okay. So how does high pressure cutout works? Can you please explain again?
If the discharge pressure, like if there is a lot of pressure developed by the compressor, this high pressure cutoff, like it senses it, and it knows that the line of the refrigerator can't take that much pressure, and if it's keep continuing it, it might burst or might leak. So it cuts off the compressor and it like turns it off
Okay. So after turning it off, does it turn on automatically or do you need to turn it on manually?
automatically.
Okay. So why do you think that there is a high pressure inside the compressor? What may be the cause of high pressure at the discharge side of the compressor?
Like if any fluid gets mixed, like water or any moisture, there is a chance of high pressure in compressor. That is one of the reasons.
Okay. So this is okay. So you said that after cutting off the after a HP cutout turns off the compressor, it turns on the automatically, right? So high pressure cutout cuts down the compressor when there is a high pressure, right?
Yes.
Then how come does it turn on automatically? Because the problem of high pressure is not yet solved, right?
Yeah, like I think it passes through, like I'm not like absolutely sure about the answer. If you can tell me the answer.
Yeah, okay. So first thing what I would suggest is whenever you are not sure about the answer, please don't give the wrong answer in a confident way, okay? So this gives a bad impact of yours to the interviewer, okay? So the HP cutout needs to be turned on manually, okay? Low pressure cutout is automatically. Okay, it works, it cuts off automatically, it cuts in automatically. Okay, whereas high pressure cutout, it cuts off automatically. But while cutting in, while switching on the compressor, we need to operate it manually. Do you know why? Because whenever there is a high pressure in the compressor, it gives an alarm to the concerned person or the officer. We need to attend it manually so as to understand why there is a high pressure inside the compressor. So the problem has to be attended manually. After solving the problem, after solving that, after getting why there is a high pressure, then he turns on the high pressure cutout manually. Okay. So this is the reason why SP cutout is set at a manually. Okay.
Okay.
Yeah. So next question is, tell me some boiler safeties.
Boiler safeties. Okay. First is pressure valves. So we usually pressure safety valves. We usually keep two of them in case one of them fails. If the pressure in boiler exceeds by a lot, then this safety valve releases some of the steam and pressure so that the pressure in boiler comes to a safe region. And the difference between these two safety valves there are around zero point 0.5 bar. Next is feed check valves, which we use to fill water inside the boiler. Uh, Next is we use blow down valve, which we use to empty out the boiler. Uh, Next is scum wall. So what happens in scum wall? It usually happens in the steam drum, and from the top layer, if there is any oil, dirt, or residue, it takes it up so that no galvanic corrosion happens. Um then next is the air vent cock. So there are two reasons why we need air vent cock. So first is when we are filling the water in, we need to remove this air. Otherwise, this air might react with the water and might cause corrosion. The other thing is cause of implosion. So what happens is when we like turn off the boiler, this whatever steam is there inside, it condenses back to water, and we know that volume of air is 1,000 times more than water. So when it condenses back to water, it causes a negative pressure, so that when next time when we use the boiler, it might cause a implosion. um, Air vent component. Steam stop valve. So this steam stop valve basically controls how much steam goes through it. But there is also a problem relating to that. That is called as water hammering, and because here also the steam that is outlet, it condenses and forms water, and when we like suddenly open the wall, all the steam, because it comes and hits the water, and there a vacuum is created, and suddenly because it suddenly cooled down, so suddenly all the steam comes and start hitting the wall, which is called as wall hammering. Then so that's our some of the safeties. And one more I would like to add is fusible plug and bursting risk also. Fusible plug, what it does is when the water level is a bit too low, this fusible plug starts getting heated up and starts melting. And the water from here directly uh, extinguishes the fire. Like it's at the crown of the fire. This fusible plug is located at the crown of the fire. And next, another safety is a low water level indicator. It indicates when there is a low water in the boiler. Another one is gauge glass. So there are usually two gauge glass fitted in a boiler. It will tell how much the boiler water has filled. We fit two gauge glass because one of the gauge glass might get blocked or choked, and it might give wrong readings to us. So the other gauge glass can give us proper readings. So those are some of the good.
Okay. So, Rakshit, can you explain me the working of gear pump?
Gear pump. So gear pump uses two gears. So one is the driver, another one is the follower. So first I'll tell how suction is created. So at the starting of the gear pump, the area is very high. Because of that, pressure will be low. So there will be creation of a low pressure area. Because of that, oil, we mostly use oil in gear pump, so oil might come there, and it starts turning. The gear pump starts turning, and because of that, the follower also starts turning. Now, at the discharge side, the area is less, because of that, pressure is high. So, a high pressure discharge is found in gear pumps. In gear pumps, we also use a relief valve because the chances of pressure increasing at very high rate is possible.
Okay. Rakshit, explain me the Archimedes principle.
Archimedes principle. So Archimedes principle states that it's like a upward force by the liquid, which is equal to the amount of liquid displaced by the body. It's a force that is imparted on the body, which is directly equal to the weight of liquid displaced by the body. That is Archimedes principle.
Okay. So, you can explain in this way that Archimedes principle is states that whenever a body is fully or partially immersed into the liquid, it displaces the some amount of liquid. Okay.
Liquid.
There acts a opposite force towards the body. So this force is equal to the weight of the liquid dispersed by the body. Okay. So please explain this way. Rakshit, that's all about your mock interview. I think I have asked you the sufficient questions. I have checked your knowledge. I think that what input I want to give is that um, you are having a clarity on almost all of the topics. Okay. So just the thing is that try to explain it in a more efficient and more correct way. Okay. You are
Okay.
having the right knowledge. You are having the right information, you know about the things, you can explain things well. So this is my input on you. So what I suggest is please go through all of the topics once again and
Okay.
try to understand all the topics once again and try to explain in a very fluent or
Okay.
chronological way. Okay.
Okay.
Yeah. Don't just look up the things, and all the best for your interview. I think most probably you will clear the interview. So this is what I think. And all the best from Team Let's Learn. Okay.
Thank you very much.
Yeah. Thank you. Bye.